Well, today I'm going to be testing this out by actually floating a small styrofoam boat in liquid CO2 and then heating it to its supercritical point. It is floating, and I'm heating it up, see if we can get to supercritical pressure here. The styrofoam is dipping deeper down in it now. The line's disappearing. Whoa, and it's kind of rising up above the surface of the styrofoam. Oh, the styrofoam sunk. It sunk down in the liquid. But now I can no longer see a meniscus on top. You can't really tell where the gas and the liquid separate from each other.
What we just saw was simply a demonstration of relative density disequilibrium. But I hear a lot of people saying, how does that actually work? I don't understand what's behind it. It's fine. I'm going to try and set it in a classroom setting as a teacher would explain to a child on a whiteboard. So let's set the classroom. The teacher: good morning everyone. Today we're going to explore the concept of unbalanced forces and how they relate to density. I want to start with a quick review. And the teacher writes on the whiteboard, and the teacher says, an unbalanced force occurs when the force acting on an object are not equal in size, causing a change in the object's motion. This can make the object speed up, slow down, or change direction. Now, how does this relate to density? Let's find out. The teacher writes on the whiteboard again. She says, density is defined as the mass per unit volume. It's a measure of how much mass is contained in a given volume of a substance. The formula for density is, and the teacher writes down the formula. Now, let's consider an example to connect these concepts. The teacher picks up two objects. She picks up a small, dense metal ball and a large, less dense plastic ball. The teacher says, here we have two balls. The metal ball is much denser than the plastic ball. If I apply the same amount of force to both balls, will they respond the same way? The teacher goes and she pushes both balls with the same amount of force. The metal ball moves at a short distance, while the plastic ball moves a much greater distance. The teacher asks, as we can see, the plastic ball moved much faster than the metal ball. This is because of the difference in the densities. The metal ball has much more mass packed into its volume, so it resists the change in motion more than the plastic ball. In other words, the metal ball requires more force or energy to achieve the same acceleration as the plastic ball. The teacher then writes on the whiteboard, says, higher density equals more mass equals greater inertia. Now, the students are probably wondering, what does she mean with inertia? Well, the teacher goes on and says, inertia is an object's resistance to change in its state of motion. An object with higher density has more mass in a given volume, thus resulting in a greater inertia. Therefore, when we apply unbalanced forces, the denser objects are less affected by the same force compared to the less dense object. It seems the children are still watching the teacher as in confused, but they're getting it little for little. So the teacher decides, let's do another one. The teacher takes both objects simultaneously. She takes a sheet of paper and a book. The teacher says, okay, let's drop the sheet of paper and this book. What do you think will happen? The students look in anticipation, wondering what is going on. The teacher drops both objects simultaneously. The book falls straight down quickly, while the paper flutters slowly to the ground. The children look with amazement and think, yeah, but that's what you'd expect anyway. The teacher says, do you know why this happened? The book falls faster because it has greater density and mass, and thus greater weight. The force acting on it is due to the object itself relative to the medium. The paper, being less dense and having less mass, is more influenced by air resistance, demonstrating how unbalanced forces can affect objects differently based on their density. The teacher in summary says, unbalanced forces causes change in motion, and the effect of these forces is influenced by the density of the objects. Dense objects have more mass and greater inertia, making them less responsive to the same amount of force compared to the less dense objects. The teacher writes down on the board again, unbalanced forces plus density equals varying motion responses. The teacher says to the students, I hope this helps you understand the relationship between unbalanced forces and density.
This is the emergency broadcast system. Stand by for further information.
Alright, just going to quickly share some full noise A-grade derp.
Because I do see people don't seem to understand things fall because of an unbalanced force. Fundamental level, because I do see people don't seem to understand things fall because of an unbalanced force. Level, because I do see people don't seem to understand things fall because of an unbalanced force.
Things fall because of an unbalanced force.
Yes, they do. They do say that. Yes, they do. A brand new job. Yes, they do. Just say no. Yes, they do.
A flat tard? Is that the case? Well, let's see what happens to the unbalanced force.
One eternity later. 2,000 years later. 2 hours later.
Hey, one man. Okay, this is just gonna be quick. I don't know if anyone's watching this moron's stream besides me, so I think that makes me a bigger moron.
Actually, do you guys think we should invite? Think about it. I can take a scale and I can even lie it sideways like this, okay?
Oh yeah.
And I can, for instance, lie an object against a scale. It will read a
So Flatsoy just said that things fall because of an unbalanced force.
Here we have two balls. The metal ball is much denser than the plastic ball. If I apply the same amount of force to both balls, will they respond the same way? The teacher goes and she pushes both balls with the same amount of force. The metal ball moves at a short distance, while the plastic ball moves a much greater distance. The teacher asks, as we can see, the plastic ball moved much faster than the metal ball. This is because of the difference in the densities. The metal ball has much more mass packed into its volume, so it resists the change in motion more than the plastic ball. Those little small cars are mini.
Motion.
Thank you very much for your $10. Actually, do you guys think we
And
transformation of that energy?
oh, and now we're up to energies again.
You move about when you walk, run, and jump in the air. A snow sled moves as it's dragged through the snow, but things can't move on their own. To move something, you need to use force. So what is a force? A force is a push, or a pull. Push forces are causing these things to move. You use a force to try to move the rope towards you. Sometimes we use both pushes and pulls to make things move.
Right, this is just going to be quick. I just want to highlight for people Flatzoid's insane freaking remarks. So objects fall because of an unbalanced force. Flatzoid.
No, it's still there in free fall. It's just people don't understand that when things are static, let's for instance say this phone, it has an unbalanced force because
Right. Now the static phone has an unbalanced force. But a moment ago, you said things are falling because of an unbalanced force. But now the static object has an unbalanced force.
Oh, it's so bad. I should have said balanced, and I said unbalanced. Oh man, I'm so sorry I made that mistake. It is forcing itself on the medium around it.
Is it? It's forcing itself.
When everything is falling, let's say with the water bottle and you've got the different things inside it, it has a balanced force. So that
Right. So that contradicts you saying that things fall because they have an unbalanced force.
Hi kids! Today we will learn what are balanced and unbalanced forces. That anything moves if some force is applied to it. Nothing moves unless some force is applied to it in one direction. Any movement is always caused by some unbalanced force. Any movement is always caused by some unbalanced force.
Any movement is always caused by some unbalanced force.
Any movement is always caused by some unbalanced force.
This is full A-grade bullshit. The only thing unbalanced is you, mate, and your intellect and your mental state. Anyway, that's my battery warning. This was only going to be a very quick one. I suggest people look at the first 20 minutes of this guy where he contradicts himself constantly. Yeah, he is the most moronic clown, dishonest cretin I have come across in this. He has no idea. All these people with density point, oh, weight doesn't exist. Sovereign soul, you just said that an object's weight depends on the medium. Well, I've just debunked you too, you fucking clown.
Hey everyone, today I'm going to be showing you how you weigh more in a vacuum. For example, I have this guy here standing on my scale. So he's starting off at 19.81 grams. As soon as I turn on the vacuum though, he starts to gain weight, 19.84. So he weighed around 0.15% more just by being in the vacuum chamber.
And anyone who's been watching these demonstrations I've been doing, and there's more to come. Oh, there's more to come. Things fall because of unbalanced force. The phone is stationary in my hand because of an unbalanced force. And then when things are falling, they have a balanced force. What the fuck are you on about?
Okay, I'm going to try and explain this in another way again. If you have a force, you have what we call inertial forces. So you have a resistance. If you have a balanced force, that resistant force is exactly the same amount of force than what you are pushing or pulling. If you have an unbalanced force, the one side of that force is more than the other. Let's put this into a way you can understand based on your demonstrations. If you drop a water bottle with water and air and an object or whatever inside it, when you let it go initially, it starts to accelerate. Notice all those things inside the water bottle have different densities. They have different amounts of inertia. This means that every object in there starts off with an impulse, different amounts of force. As soon as it starts to accelerate, it will not have any properties of separation because they're all accelerating now with a balanced force. The water, the air, the object inside, and the bottle all accelerate in the same direction at exactly the same velocity. So therefore, net force of 0. When that bottle now reaches terminal velocity, it will now have a unbalanced force again, because everything inside there now has its separate weights attributed to it. So the denser water will now go to the bottom again, the air will now separate to the top again, and whatever object inside, based on its density relative to the medium, will move to its relative position. The bottle, on its other hand, is still accelerating down to the ground. Notice that the forces imparted are different. The bottle itself is now in a reference of having balanced force, but the objects inside it are having unbalanced forces because they still have their different densities. I don't know how much more clear I can make this, but that is how physics works, Execrate and Dal.
Anyway, this dude doesn't wind me up. Do not confuse my passion for this subject as having a passion towards this guy and his personality. He's a fucking retard.
Okay, now let's let it cool down a bit, and it should revert from it's supercritical state into a liquid with gas above it again. And I think the styrofoam should float once again. Okay, I'm gonna put an ice cube on top. It's starting to float. And it's back on top. So why did this boat sink when it went supercritical? Well, if you think about it, right before it turns supercritical, there's a liquid on bottom and a gas on top. Since the boat is floating right on the surface of the meniscus, that means the average density of the boat is more dense than the gas, but less dense than the liquid. But then once it becomes supercritical, these two states suddenly become one. So it would make sense that the density of the remaining fluid should be some average of these two states.